All right, guys. This is the practice AROC and linear regression worksheet for homework tonight. Remember, we are always rounding final answers to the nearest thousandth, which is 3 decimal places. And we're going to use this graph below to answer parts A through E. So the graph shows net profits in billions of dollars for Apple for each year X, 2010 to 2017. 0 represents 2010. Find and interpret the average rate of change between 2013, so that would be this point, and 2017. Now we can go to Desmos. Remember, we're practicing Desmos with our calculators, I should say. So if I want to calculate that slope, I can say 48.4 minus 37. I forgot to hit my divided by sign, so I can highlight the whole thing and say divided by. Divided by 7 minus 3. So that's coming out to 2.85. I do need to show, or I should show my work for this. So I'm just going to write down those numbers. That came out to 2.85. Just double checking that. Yeah. And then interpret. So remember, we have a script for this. On average, we're talking about, what is this? Net profits. The net profits increased by 2.85. This is a dollar amount in billions. And that's happening per year. You have to have the phrase on average because that's not the true slope between every consecutive year. Which interval contains the lowest average rate of change? So remember, lowest is just the lowest number. So are there any negatives? Yes, we have a negative here and here. And so whichever is more negative, I can kind of, just looking at this, I think I can kind of see. But if you're not sure, you could crunch the numbers here. So let's see. The first one is, on a new line, 37 minus 41.7. So that's a drop of 4.7 in 1 year. And then the next one is 45.7 minus 53.4, negative 7.7. So that's, there's a more drastic drop here. That's the lower number. So which interval? That would be between 2015 and 2016. And I'm going to say it has the most negative, I don't know what's going on with my pen, most negative slope. Use the points on the graph to create a linear regression model for the net profit as a function of time. So we need to enter these data points into Desmos. So I'm going to clear out my old stuff. To do this, you add a table and type in the x coordinates first. So 0, 1, starts guessing for you all the way out to 7. And then we need to enter this data in. So 14, 25.9, 41.7, 37, 39.5. Make sure I'm putting these in the right order. 53.4, 45.7, 48.4. Once you get your data entered in, to view it, you can click Zoom Fit. So there's the data set. We were told to do a linear regression, so choose regression. It's linear by default. If you had to do a different kind, you could choose from the drop-down list. And remember, it's kind of nice to have this equation to work with if you're supposed to be plugging into it. So click this little box and it'll copy the equation into the line below. So let's go ahead and write this down. Y is equal to, make sure you don't round any of this. Include all of the decimal points for your model. We do round final answers to 3 places, but you don't want to round within your work because then your final answer will be thrown off. All right. So this is the model. and then use the linear regression model to predict Apple's net profit in 2020 and in 2024. Which prediction is likely to be more accurate? So before I even calculate these, the one that is more accurate is always the one that's closer to the original data set. Excuse me. So the original data set goes from 2010 to 2017. So 2020 is closer to 2017 than 2024. So the 2020 prediction is more accurate because it's closer to the, I'm going to say original domain. Remember, domain is just like the original set of inputs used to build the model. And then y of, it's not y of 2020. These are years since 2010. So y of 10 and y of 2024 then would be y of 14. Now, how do we do that in here? We just, this is why I copied the equation right here. So we click in here. I like to put just parentheses around the x, and then I'm just going to come in here and type in 10, write down that number, 67.404. And again, this is billions of dollars, label it. And then I want to just make an adjustment here, change that to a 14, 85.375. Labeling with a $sign and billions. The residual plot is shown below for a linear regression model. So this is not necessarily the data we just had. Oh, maybe it would. Oh, sorry, this is the data we just had. Based on the residual plot, is the linear model an accurate model for Apple's net profit between 2010 and 2017? Based on the list of residuals, does the model overestimate or underestimate the net profit in 2012? So let's answer the first question. I briefly mentioned this in class. We're not supposed to see a clear pattern in the residual plot. It's hard with so few data points, but I would say it's kind of hard to make a final decision from a residual plot, but there's no clear pattern in the residual plot, so the linear model might be appropriate. If we were really investigating this, we would try some other models and see if any of them have better residual plots or higher correlation. Based on the list of residuals looking at 2012, which would be 2, does the linear model overestimate or underestimate? So remember what this means. You have this line of best fit, and if we have a positive residual, it means that the line is sitting below the data point at 2012. So because the line is under the data point, the linear model underestimates the data for 2012. All right. The table below shows the sale S in billions of dollars for Nike Incorporated for each year from 2011 to 2017, where 1 represents 2011. So we have this table. Find the average rate of change as a decimal approximation from 2011 to 2017. Show the work that leads to your answer. So they're asking me to find an average rate of change. I'm going to do 34.4 minus 20.9 over 7 minus 1. I'm going to let Desmos do that for me. I'm going to X out of my old stuff here. All right, so that was 34.4 minus 20.9. Down here, I'm just going to say that's 6. So up 2.25 again. And this was in billions of dollars per year. Use S of 7 and the average rate of change calculated in Part A to approximate the sales for Nike in 2024. Okay, so this is kind of different. We didn't do this in our notes. So what do I mean by that? So use the ordered pair 7, 34.4, and use the slope 2.25 to approximate the sales for 2024. So remember, this is years since 2010. So this would be T equals 14. So let's write a point slope equation using that point and that slope. And then we can plug 14 in for, I guess I should have done, T and S here. And let's just plug that in. So plug in 14. So S is equal to 2.25 times 14 minus 7. And then we would have had to add the 34.4 over here. So let me see what that comes out to. Doesn't want to split screen for me. Oh. Sorry, technical difficulties. There we go. All right, so let's calculate that. So 2.25 times 14 minus 7 is just 7. I'm really having issues here. Plus 34.4, 50.15. And again, that's billions of dollars. I didn't have room for a dollar sign, so I'm writing the word dollars. That's just our approximation for S of 7. Use a linear regression to create a model for Nike sales as a function of time in years since 2010. So we are going to enter this table into Desmos. So again, to add a table, you go to plus, table, start typing stuff in. So this is 1, 2, 3, 4, 5, 6, 7. I like when it starts guessing my pattern for me. Carefully type this data in: 20.9, 24.1, 25.3, 27.8, 30.6, 32.4, 34.4. If the window isn't already fit to that, you can hit zoom fit. And then they wanted a linear model, so I click regression. It's already linear regression, so there's a nice line. And in case I have to plug stuff into this equation, I'm going to copy it into the next line. All right, so we need to write this down. Remember, when you're writing your model, you want to use the correct variables if they're given in the table, and you don't want to round anything. So instead of y equals, it's going to be s equals 2.22857, and not x, but t. There we go, plus 19.01429. Use the linear regression model to approximate the sales for Nike in 2024. So 2010 is 0. So this again is S of 14 is what they're asking me to find. So if you haven't already done this, copy this equation down onto the next line by clicking here. And then you can just swap out the X for the number you want. What did I say? 14. And that gives me 50.214. And again, that would be billions of dollars. Pretty close to what this answer was as well. So they're a bit off, but pretty close. The list of residuals is given below. Which point is farthest from the linear regression model? So that could be positive or negative. So let's look at that. In absolute value, which number is the biggest? 0.6 looks to be the largest to me. So which point is farthest? So 2, 24.1 has the largest distance, I'm going to say, from the model. Okay, now if that is a positive residual, again, that means you've got a line of best fit. The point is sitting up here. The line is under the point. So does the linear model, the line, over or underestimate the sales? The model, it's under the actual sales, so it underestimates. The sales for, what is that? 2 is 2012. All right, we're getting used to using Desmos. We're getting used to kind of looking at data and explaining our answers. So please come and see me during office hours if you need extra practice with any of this or you need help with any of the tech stuff.